Dear students, in the following recording, the video didn't come up right. I apologize for that. Please consult the internet web page. Follow the lecture from the internet web page. I apologize for that. Please bear with me. Thank you. Now, in this part of the future of flight discussion, we will have a look at the rebirth of supersonic flight. Faster than sound, supersonic airplanes could make a comeback. 3 American companies are developing them. On October 24, 2003, Concorde made its last commercial flight. It carried a full load of passengers, 100 of them, from New York to London, and it did so in 3.5 hours. It was able to make the journey so rapidly because its top speed was Mach 2.04, just over twice the velocity of sound. In its day, Concorde. So this is a nice historical background of supersonic travel. In its day, Concorde was a superb piece of engineering, but it was also a vanity project. What is a vanity project? We will learn it in the next sentences. But it was also a vanity project cooked up in the early 1960s by the British and French governments. So it's a government project. But a vanity project doesn't mean a government project. Issues like profit were ignored. So this project was supported by the governments, and issues like profit, economic feasibility were ignored. However, superb the engineering, with the technology then available, the profitable operation of such a supersonic plane was impossible. So it is called a vanity project because the government spent the money. They knew that they are not going to recover because the project was not an economically feasible one. So at this point, I want to show you on the presentation 2 documentaries about the Concorde project. I think you will find them interesting. Let's learn more about the innovations happening to bring back supersonic flight. Technology moves on, though, and several truly commercial undertakings think the time is now ripe for something similar. Most of the running is made by 3 American firms, Ariane, Boom, and Spike. So these 3 companies building projects are doing projects to bring back supersonic flight. Ariane's offering, the SAS-2, is a 12-seater intended to fly at Mach 1.4. So this is a 12-passenger, 12-seater aircraft, including the pilot. Remember, the Concorde was a 100-passenger aircraft. Overture, the aircraft planned by Boom, will get to Mach 2.2. It will carry 55 to 75 passengers. And Spike's proposal, the S512, lies between these 2 extremes. It is intended to carry 18 passengers at Mach 1.6. All 3 firms think that improvements in materials, engine design, and the understanding of aerodynamics mean their proposed craft can be operated profitably and without too much discomfort in the form of sonic booms, that unbearable noise. One hears the sonic booms that is followed by a supersonic aircraft flying to those on the ground below. Because Concorde's flights were extremely painful for the people living near to the airport due to those sonic booms. So new understanding in aerodynamics and modeling can help today's aircraft manufacturers deal with that sonic boom, make it less powerful and more, therefore, bearable for the people on the ground. So if we can look at the presentation here, we have three companies, American companies, Ariane, Boom, and Spike. Their aircraft looks like this. So this is the Ariane 12-seater, Mach 1.4 speed. That is Boom, larger aircraft, up to 75 passengers, flying at Mach 2.2. And this is the Spike, 18 passenger aircraft, flying at Mach 1.6. Okay, let's have a look at these projects in a little bit more detail. In February 2019, again, Ariane signed a development deal with Boeing. It also has an arrangement with GE to develop a supersonic engine called Affinity, capable of operating efficiently both subsonically and supersonically. The plan is to attach these, 3 at a time, to an airframe built by Spirit Aerosystems, a large manufacturer of airframe components. So this is like a consortium, Ariane, Boeing, GE, and Spirit Aerosystems. All this will come to pass, Ariane claims, by 2023, the current target for the AS2 to take off. Not very far, not much far. We will be beginning to see if everything goes according to the plans. So next, what about the Boom? Boom has yet to announce a propulsion system for Overture, but it too has development money, having received a tranche of 41 million in venture funding in 2017 and a further 100 million this January 2019. So these are the investments to start with for this type of projects. And it will soon have a prototype, 1/3 scale aircraft that it calls Baby Boom. This small-scale version is powered by 3 of General Electric's J8515 engines, the military versions of the CJ610, an established workhorse of business jets. All being well, Baby Boom will take to the air early next year and fly at Mach 2.2. So it's worthwhile to watch Boom's aircraft. And lastly, Spike. Spike has yet to pick an engine, though it plans to do so by the end of the year, that is last year. It also plans a subsonic demonstration flight in June 2019 and a supersonic demonstration in 2020. Whether supersonic commercial aviation really will work this time should thus be clear by the mid-2020s. A few visionaries, okay, before going there, let us do a review of Ariane project, Ariane's AS2 project. Okay, next. So we said improvement in materials, engine design, and aerodynamics is now bringing back the supersonic flight, making it this time profitable. It was not profitable before. It was a government vanity project, remember? Profitable and quieter. Okay. And Ariane is one company that is busy with this work. They made a team with Boeing. Boeing is going to do the development and integration. GE with its Affinity engine will make the aircraft fly super and subsonic, and Spirit Aerosystems is providing the airframe for the aircraft. Okay, coming back. Good. So we have to see maybe in the first half of 2020s, there is a high probability that the supersonic aircraft will be commercially available. So if that is the rebirth of supersonic flight, there is something even more exciting, which is hypersonic, flight. A few visionaries are, however, looking beyond the merely supersonic. They want to go hypersonic, beyond Mach 5. That would make it possible to fly to an airport's antipodes in less than 4 hours. An antipode is the opposite side on the sphere, on the global sphere. On Earth, an antipode is the diametrically opposite position. For example, the antipode of UK is Australia. So, what is the antipode of Turkey? Can you find it on the globe? At this hypersonic speeds, the physics gets scary. Air entering a hypersonic jet engine would be traveling at more than 1.7 kilometers per second. Slowing this air down sufficiently for it to be manageable would convert its kinetic energy into heat so intense that it would melt most of the materials of which such an engine might be made. Now this is a really scary speed. So about 5 Mach, that is about 5,000 kilometers an hour. This is really the speed that one encounters in astronautics, not aeronautics. This is almost approaching the escape velocity or the re-entry velocities of spacecraft, which are of course designed for this extreme heat, extreme temperature built up in the vehicle. So you don't really want your large jet engine face, or at least its turbines face, this type of a speed. So how can one make hypersonic engines then? The next paragraph tells us a little bit more about this point. All this explains why existing hypersonic vehicles, namely satellite launchers, are rocket-propelled. So these are rockets with no jet engines. They are rocket engines. A rocket carries its own oxidant and so does not need to breathe air. The only alternative that has been tested experimentally is called the supersonic combustion ramjet. So this is an alternative to the rocket engines that can push vehicles to hypersonic speeds. This does not require, the supersonic combustion ramjet doesn't require the incoming air to be slowed down to the same extent as a turbofan, but it has to be accelerated to Mach 5 to start operating, usually by a rocket. Unfortunately, this type of an engine, called a scramjet, has to be accelerated to Mach 5, then it can start working. Therefore, one needs a hybrid system in order to use a scramjet. A small British company is exactly doing that. A small British company. Okay, before that, I should show you what a scramjet looks like. So, This is what is scramjet. So there are no fans here. Therefore, the incoming air is not really stopped or slowed down at the entrance of the scramjet. So coming back, a small British company called Reaction Engines does, however, have an alternative on offer. Skylon, as it calls its design, would be powered by engines able to switch between air and liquid oxygen. It says oxygen here, but it should really be hydrogen. They are known as synergetic air-breathing rocket engines, SABRs, and would be fueled by liquid hydrogen, which has a temperature of less than 20 degrees above absolute zero. So that is minus 250 degrees centigrade. The trick when a SABR is in air-breathing mode, so this is basically a rocket engine packed with a jet engine. The trick when a SABR is in air-breathing mode would be to use this coldness to absorb heat generated by the inrushing air before it could cause damage. So also they will be using liquid hydrogen as a fuel and also as a coolant in this approach. A heat exchanger intended to do this was tested successfully in April. So I have so this is the reaction engines Skylon. I have a video for you to investigate there. Also, I provided a PDF that shows the space shuttle. The space shuttle achieves 5 Mach in just 3 minutes, and ultimately it arrives to 27 Mach for escape velocity. Coming back, okay, the article is actually evaluating this type of a hybrid engine, and perhaps not so optimistically, but by saying, at best, the chances of a tiny team working in the metaphorical equivalent of a garden shed cracking the problem of air-breathing hypersonic flight are slim. In other words, this is not a small project to be done by at your backyard. This is the point the article is making. So the problem is air-breathing hypersonic flight. If you want a challenge, this is a challenge for you. Air-breathing hypersonic flight. That is not an easy problem to solve. But also it says perhaps they are not zero. The chance is not zero. The fundamental design of these people looks good, sound, and there has over the years been enough interest from outsiders such as Boeing, Rolls-Royce, and BAE, British Aerospace Enterprise, to keep the dream alive. So this is not like cold fusion, it seems. There is a chance that one day it could be feasible, a stable solution can be found for air-breathing hypersonic flight. Hypersonic missiles are, for example, available, but of course they are basically rockets, propelled with rocket propulsion. And let us conclude this with, if Skylon does eventually fly, its first use is likely to be as an unmanned spaceplane, carrying objects into the orbit. But one day, perhaps, it or a successor will, for those rich enough, make popping over to Sydney for a weekend break seem just a thing. If hypersonic flight will be common, of course, it will be about 4 hours to fly to the antipode, to the other side, to the opposite side on the Earth. So this article concludes with that utopian dream, maybe awaiting us, maybe in the 2020s. So supersonic flight, we will have an answer for that in the first half of 2020s, and hypersonic flight is also in the research agenda. That's what we learned from this article. In the next article, we will have a look at electric propulsion and flying taxis. Thank you.